Welcome. Today we're going to crack a really fascinating puzzle. We're going to look at two things that seem totally unrelated, a coin toss and a game of plinko. But what if I told you they're actually the exact same story, just in disguise? Let's dive in. So yeah, what is the connection here? A simple coin flip versus a marble bouncing its way down a board full of pegs. The answer, believe it or not, is more than just a cool piece of trivia. It's actually a key that unlocks a whole new way of thinking about chance and probability. Okay, so take a look. On the left, you've got your coin toss outcomes. On the right, the plinko board. They both look pretty simple, right? But here's the thing. Our gut feeling about how these games work is often, well, flat out wrong. And we're about to find out why. To really get why our intuition can lead us astray, let's start with our first story. It's a simple bet between three friends, but it hides a really important lesson about how much the details matter. So, picture this. You've got Adam, Bill, and Cameron. They're flipping two coins to see who gets the last slice of pizza. Adam calls two heads, Cameron calls two tails, and Bill says, I'll take one head and one tail. Okay, so, three people, three different outcomes. That seems totally fair, doesn't it? But is it? And right here is where it all gets a little bit messy. It's all about the language. When Bill says one head and one tail, what does that actually mean? Does it matter if the head comes first or the tail? Is heads then tails different from tails then heads? This kind of fuzzy language is a classic trap in probability, and it's exactly why we need to be crystal clear.
So, to get rid of all that confusion, we have to map out every single possibility. In math, this is called the sample space, which is just a fancy way of saying, let's list everything that could possibly happen. And with two coin flips, there are only 4 equally likely outcomes. You can get two heads, a head then a tail then a head, or two tails. That's it. Each of these has the exact same 1 in 4 chance.
Now let's see how this breaks down for our friends. Aiden's bet on two heads, that only matches one of our outcomes, HH. So he's got a 1 in 4 shot. Same for Cameron, and two tails. That's just the TT outcome, another 1 in 4 chance. But look at Bill. His claim of one head and one tail actually covers 2 of the possibilities, both HT and TH. That gives him a 2 in 4 chance, which is a 1 in 2 or 50% chance of winning.
So, was it a fair bet? No way. Not even close. Bill has literally double the chance of winning compared to his friends. It looked fair on the surface, but the moment you investigate the actual process, you see the hidden advantage. Okay, so hang on to that idea of digging into the process, because we are about to see the exact same principles show up again, just wearing a totally different costume. Let's move on to our second mystery, the plinko puzzle.
All right, here it is, the plinko board. A marble gets dropped in at the top, and every time it hits a peg, it has a 50-50 chance of bouncing to the left or to the right. Eventually, it works its way down and lands in one of those 3 bins at the bottom, A, B, or C. Simple enough, right? But you probably know where this is going.
Here's the trap our brains fall into. You see 3 bins, so you immediately think, okay, it's a 1 in 3 shot for each bin. A third, a third, a third. It just feels right. But as we just learned with those coins, our first instinct can be really misleading. And this is the big aha moment for this puzzle. The bins themselves are just the finish lines. They are not the fundamental equally likely outcomes. The real outcomes are the different paths the marble can take to get down the board. To find the real probabilities, we have to follow the journey, not just stare at the destination. So, let's do that. Let's actually trace the marble's journey, decision by decision, and see what's really going on here. So in this simple setup, the marble basically makes 2 choices. At the first peg, it goes left or right. Then at the second layer of pegs, it again goes left or right. 2 layers, 2 50-50 decisions. Does that sound a little familiar? It should. And those 2 simple decisions create 4 distinct, equally likely paths for that marble to take. Left, 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 right, right, left, and right, right. Wait a second. That's just like heads, 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 tails, heads, and tails, tails. It's the exact same sample space, just with different labels.
Okay, so let's map these paths to the bins. The only way for the marble to end up in the far left bin is to take the left path. And the only way to the far right bin is the right path. But look what happens in the middle. Both the left-right path and the right-left path funnel the marble into that center bin.
And this chart makes it perfectly clear. The left and right bins each catch only one path, so they have a 25% chance. But that middle bin, because it collects 2 of the 4 possible paths, has a 50% chance of getting the marble. So much for our 1 in 3 guess, right?
So, now we've solved both puzzles. It's time for the big reveal. Let's put them side by side and finally pull back the curtain to see what's been hiding in plain sight all along.
And there it is. The connection is undeniable. Look at this. They're identical. Heads, heads is the same thing as left, left. Heads, tails is the same as left, right. Bill's winning bet of getting 1 of each is the exact same probabilistic event as the marble landing in the middle bin. They are 2 completely different stories, built on the very same mathematical blueprint.
So why does this matter? Who cares if a coin toss and a plinko game are the same? Well, it matters because this isn't really about games. It's about learning a powerful new way to see the world around us.
In fact, you can think of it as a checklist for what we could call process literacy. First, just name the random actions, like a coin flip or a marble bounce. Second, decide what one basic outcome looks like. Third, and this is crucial, list all of them. 4, group those outcomes into the event you actually care about. And finally, 5, you just compare by counting. This simple 5-step process can help you see through misleading surfaces almost anywhere. And it really all comes down to this one powerful idea. When you're faced with a question about chance or probability, don't just look at the surface, look at the process, because that's where the truth is hiding. So the real question is, what other situations in your life might have a hidden process at play where the odds aren't quite what they seem? It's something worth thinking about. Thanks for joining me.